right here, speed, say first one 50, second one 60, 65, 55, 65, 60, 55, 75, and 65. Total 9 data available. So in this case, if we want to do in Excel, what shall we do? So one sample t-test is not available in Excel. Could you see this screen? Can you see the splitter screen in your sharing data area? So can you see both screen, no?
Yes, sir.
Okay. So in Excel, normally this one is not available. Which one is not available? One sample t-test not available, right? So data, inside of data menu, data analysis, inside of data menu, data analysis. If it is not available, this data analysis, then go to click the file and go to the option, right? In this option, one menu is available, add-ins, right? You can choose the add-ins, you can select the add-ins, right? You can choose the add-ins. In this case, already add-ins added. So select add-ins and analysis tool pack. Then it should be display what are the things we want to know. So you can click that one and click OK. Click OK. Then that should be appear, right? So this data analysis is not available. You can go to the file, option, select the add-ins. In this add-ins toolbar, you can choose the analysis tool pack and then click go. Then tick first two option and click OK. Then the data analysis toolbox should be displayed. In this data analysis, here there is no one sample t-test. There is no option for one sample t-test. So we have only two sample assuming equal variance and unequal variance. So in this case, right? In this case, what is the method is most suitable? I can put one dummy variable. I can put one dummy variable. I just enter two data, right? Two data for this dummy variable. Now I have two columns. One is speed, another one is dummy, right? One is speed, another one is dummy. So data analysis. In this data analysis, t-test, two sample, assuming unequal variance. Two sample, assuming unequal variance because the speed already contain data, dummy variable 0. So there is no point of view to compare the variance are equal. So that's why I can choose unequal variance and click the first range. So in this range, I choose the label as well. In the second range, I can choose the second range data. We want to check whether the hypothesized mean value is equal to 55. Already the label also selected in this list. Due to that, I want to ignore the label. Due to that, I choose that one. Alpha is equal to 0.05. I want to choose the output. Where did you display? I click here, right? The output should be displayed here. Otherwise, if you want to display that one in a new worksheet, you can click here and choose the new worksheet. In my point of view, I wish to display the output in this area, so I can choose the output here and click OK. Is it okay? Up to this step, if you have any problem? Hello? Up to this step, do you have any problem? Shall I go? No?
Excuse me, sir.
Yes.
What is the meaning of hypothesized mean difference?
So that is the alpha. That is the H node. So in this case, so here, say the government claim car traveling past your house average 55 miles per hour. So normally the assumption is moving each and every car speed is 55 miles per hour. So our null hypothesis, the cars are passing through our house. The speed of the car is equal to 55 miles per hour. That is the null hypothesis. Alternative hypothesis, that is the car passing from our house not equal to 55 miles per hour. So our null hypothesis, the cars are passing from our house is 55 miles per hour. Alternative hypothesis, that is not equal to 55 miles per hour. That's all. So due to that, we want to check whether the mean difference is equal to 55 or not. Due to that, we can put the mean value 55. Is it okay?
Okay, sir. Thank you.
Okay. So then click OK. Then we can get the results. In these results, right? In these results, so it will give 2 sample t-test value, but the results remaining depend on 1 sample. Here, the 2 sample, this one, what is the tail? 1 tail or 2 tail test? 1 tail or 2 tail test? 1 tail or 2 tail?
One day interest.
Why? Average 55 mile per hour. No more word says less than 55 or greater than 55. So this one is equal to 55, right? Average 55 mile per hour. So this one, in this case, we want to consider the 55 mile per hour. So the alternative hypothesis not equal to 55. So 2 tail test, right? 2 tail test, right? Say due to that, I can choose the 2 tail test. The value is equal to 0.038. This one less than alpha 0.05. Then we can reject the null hypothesis. The value 0.038 less than 0.05. So we can reject the null hypothesis, accept the alternative hypothesis. The car speed are passing from our house. The average car speed not equal to 55 miles per hour. Is it okay? Hello, if you are not saying yes or no, or if you understand or not understand, how can I assume?
Okay, sir. Okay.
Right? Is it okay? Shall I move? Right? So Excel part is over. I close it down. Right? Now we can see the same question in SPSS, right? So in SPSS also, in the variable view, write name, say speed speed is the one and only one variable, I can set that value is equal to with 3, no more decimal needed, right? And then go to the data view, speed. Now I can enter the value 50, 60, 65, 55, 65, 60, 55, 75, 65. Right? Now in SPSS, we already entered the data in SPSS. Go to the analysis menu, compare mean, one sample t-test. So only one variable speed. So I can move the speed in our test variable. Test value is equal to 55. Why? We want to check whether the value is equal to 55 or not. This is nothing. So, and then click OK. And then click OK. Say, in this case, one sample t-test statistics. Here, degrees of freedom is equal to 8. Significant two-tailed test, the value is equal to 0.038. So the value 0.08 less than 0.05. So we can reject the null hypothesis and accept the alternative hypothesis. That meaning is the average car speed not equal to 55 miles per hour. One sample t-test is over. If you have any doubt,
Select for this t-test where we want to click.
Can you explain again?
Yeah, if you want to select the t-test, go to the analysis menu. So all other test is available in this analysis. In Excel, that is available data analysis. In SPSS, it should be available analyze menu. In this analyze menu, go to the analyze menu, then compare mean. What is the thing we want to compare? We want to compare mean. So normally one sample t-test or two sample t-test or paired sample t-test or one-way ANOVA, each and every test we can compare mean, right? So we are not worried about how many samples is available inside the group. Only we have to check whether the group mean are equal or not equal. In one sample t-test also, we can check the mean value is equal to 55 or not. Two sample t-test, no need. How many samples is available in the group A and group B? We want to check the sample mean group A and sample mean group B is equal or not equal. So only we can check whether the sample mean is equal or not equal. In one-way ANOVA, if you can choose 3 or more groups, then you can check whether each and every group means are equal or not equal. So all of the examinations come to compare the sample mean are equal or not equal. Right? So due to that, we can select compare mean and select the one sample t-test, right? Give me 2 minutes time, I will come back. So Sorry for the inconvenience. Right. Is it okay? Is it okay?
Yes, sir. From this, sir, how we get the conclusion, sir? After we get the t-test,
Yes.
how we conclude it, sir? It is so through the results how we conclude.
So how we can write down how we can justify our result? Is you asking?
Yes, sir.
Yes,
What
sir.
is the null hypothesis? What about like that?
Yeah, that's the thing actually. In this example, the null hypothesis, we can say the null hypothesis, the average speed of the car is equal to 55 miles per hour. That is our null hypothesis. Alternative hypothesis, the average speed of the car is not equal to 55 miles per hour. Right? So the conclusion in the significant value alpha, significant value 0.038, that is the significant value of this one sample t-test, right? The significant value 0.038 less than 0.05, that means the value of alpha is higher, the significant value is less, then we can reject the null hypothesis. That is the rejected. Normally, if you are calculating or if you are analyzing, you can get the p-value or significant value. That value is less than 0.05 when we can choose 95% confident interval. So the alpha is 0.05. If it is less than, then we can reject the null hypothesis, accept the alternative hypothesis. Then what do you mean for that? We can reject the average car speed 55, we can reject. So automatically we can accept the average car speed not equal to 55. It may be go up or go down, right? So here I already shared in this case the same page I already shared last time. This is the null hypothesis, the mean value is equal to 55, right? Alternative hypothesis, the average speed is not equal to 55. This guess, stay, any difference is due to the transmit effect, right? So then we can conclude here the value is this value is less than 0.05, right? Why we are choosing 95% confident interval, then we can reject the null hypothesis and accept the alternative one. Here, statistical summary, the p-value or the t-test 8, that is the table value. Then we can, using this table also, we can calculate. So no need, the significant value is directly getting from this table. So the significant value 0.038 less than 0.05. So we can reject the null hypothesis. That means the average car speed not equal to 55. The research hypothesis was supported. The average speed of car was significantly faster than the stepped speed. Mu is equal to 55, right? Because this value is less than or equal to 0.05. The effect size was large. Is it okay? Hello?
Yes, sir.
Okay, sir.
Okay, sir.
So this is the one sample t-test, right? So
Excuse me, sir.
yes.
So without typing, why that in the data view, In speed column, why there are question marks coming?
No, if any question mark is come in your SPSS application, it should be the installation problem. You are not installing your application in the correct format. You can recorrect it. So if you enter the data, if you set the variable view and come to the data view says question mark, no?
Yes, sir.
So if it is automatically display the question mark, that means your SPSS has some problem to the installation. So in SPSS, so we have another advantage inside of this SPSS. So we can read all the statistical tests, right? All the statistical tests available inside of this SPSS, right? So topic, tutorial is also available, case study, right? I want to go to click this case study, right? So I am little bit faster, a little bit longer from my connection. Due to that, the connection is little bit slow. What's happened? My voice is come on time, or it will take some time? If you have
On
any
time.
it's okay, then okay. So in the introduction, so many things is available. So in the statistical base, I can go to click the t-test, right? Here, t-test, one sample t-test, paired sample t-test, independent sample t-test. If you can go to click one sample t-test, the theory is also available, right? And one sample t-test, some practicals also available, right? Go to click this one sample t-test and move this arrow, right? Move this arrow. Then you can see one question is available. A manufacturer of high performance automobile produces disc brakes. A manufacturer of high performance automobiles produces disc brakes that must measure 322 millimeter in diameter. Quality control randomly draws 16 discs made by each of
Excuse me,
8
sir.
production machines.
Sir,
Yes.
sir, we can't see the questions.
Oh, sorry. Right? Sorry, then I will come again. In this introduction, so if you go to the help and select the case studies in the SPSS, can you see in the SPSS screen?
No, sir.
So okay, in the SPSS screen, go to the help menu, and the third option, case studies, right? If you go to click the case studies, then this type of help menu should be displayed. In this help menu,
Sir, still also you are in the browser, sir.
Okay, sorry. Now can you see?
No, sir.
We can see, sir.
We can see, sir.
Yes.
Now okay.
Okay, sir.
The title of this one, a production line problem.
Yes.
Okay, sir.
So okay. So then, if you want to go to this question, so I can go to the introduction and then go to the subtitle t-test, right? go to the subtitle t-test, right? And then click the one sample t-test. Inside of the one sample t-test, example is available, right? Say a manufacturer of high performance automobile produces disc brake, right? A manufacturing company, it can be produce automobile disc brake that must measure 322 millimeter in diameter, right? Normally, the disc brake size should be 322 millimeter diameter. So quality control randomly draw 16 discs made by each of 8 production machines and measure their diameter. So the quality control check whether the machine produce disc brake, it should be follow the quality control test. It should be 322 millimeter diameter or not. The production lineup has 8 machines, right? 8 machines. So the quality control guys, they can choose 16 disc, 16 sample in each machine. So the total sample is 8 into 16. Is it clear? Hello, is it clear? The question is clear? Hello? 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 Hey, the question is clear. Line is not clear. Oh, hello, hello, hello.
Yes, sir.
Line is okay. My voice is okay.
Okay.
Yes, sir.
Are you hearing? Okay. So then this example uses file break.sav, right? Break.sav. See the topic sample file. For more information, use one sample t-test to determine whether or not the mean diameter of the brake in each sample significantly differ from 322 millimeters. Right? So I want to do this exercise. I want to test this exercise. I will return back to SPSS, right? I will return back to SPSS. Can you see the SPSS screen?
Yes, sir.
Yes.
Okay. Right? In this SPSS screen, in this SPSS, I will go to open the break.sav. That file is available inside the SPSS software, right? Inside the SPSS software, this file is available. So if you can write down, so you can write down the path. Otherwise, it has some problem to search to find out this path, right? File, open, data, right? File, open, data, and then choose the local disk C. Choose the local disk C, wherever your program is installed, right? Wherever the program is installed, and then go to the program files, and then go to the program files. Inside of this program file, another folder is available, IBM, right? Another folder is available, IBM, right? Inside the IBM, another folder is available, SPSS. Inside the SPSS, another folder is available, statistics. Inside the statistic, another folder name is 20, statistic 20. Inside of the folder 20, so many folders is available. You can go to select sample. Inside the sample, the folder name is English. You can open the English. Then all the sample files should be displayed, right? All the files should be displayed here. break.sav, it's my file. Shall I repeat it again or no need? So file, open data. If you go to open the data, then choose wherever the SPSS is installed. If it is in C drive, select the C drive and then program files. Inside the program files, IBM, inside the IBM SPSS, inside the SPSS 20, inside the 20 English, sorry, inside the 20 samples, inside the sample English. So inside the English, all the sample files should be here, right? I will repeat the step again. File, open, data, right? Look in, I want to look in the C drive, right? And then program files, and then IBM, and then SPSS, and then statistics, and then 20, and then samples, and then English. So break.sav, that is the name of the file, right? I select the file and put the command open here. Now you can see the first machine, it can be contain 16 samples. So the diameter of the sample is 322 or 21 or something, right? Do the same, the second 16 sample, it's fully based on second machine. It contains the break diameter. So up to 18 to 16, 128 record should be here, right? So in our first case, what's happened? So one sample is given. We want to check whether the sample size should be follow the particular mean value. It should be the sample size, the average mean value is equal to 55 or not. That is the previous question. The previous question, sample is given. We want to check whether the sample mean is equal to 55 or not. In this case, we can choose 8 machines, 8 different machines. Each machine produce samples, right? So in this case, we want to consider this machine produce sample disc break. It should be follow the quality control rule. Second machine, it should be follow the quality control rule or not. The third machine, it should be follow the quality control or not, right? So due to that, we can split the file machine wise, right? We can split the file machine wise. Why we are split the file machine wise? We want to find out first machine. This first machine produce break, follow the quality control rule or not. Second machine produce disc breaks, follow the quality control or not. So do the same rest of the machine. So each and every machine produce disc break should follow the quality control or not. The meaning for that one, we want to check the disc break diameter with the machine number, right? With the machine number. Are you agree? Could you understand what I say? Hello?
Okay, sir.
So In our previous example, we are not worried. We can directly go to click the okay. Here in this example, here the first machine produced 6 samples. I want to give the report. I want to give the explanation. I want to give the suggestion. First machine follow the quality control, or first machine produced disc brake follow. First machine produced disc brake follow 322 or not. Second machine produce disc brake follow 322 or not. One minute. சரி ஒரு ஆள் வருது. Right? So every machine with its diameter, it should be follow the disc brake. It should be follow quality control, accept or reject. Each and every machines, right? Don't merge all the machines. We want to consider machine with sample. It should be follow 322. We can accept the quality or reject the quantity. We can accept the machine or reject the machine, right? That is the case. Is it okay? So if I want to check the sample with machine, I want to split the file with machine wise. I want to split the file with machine wise. So if I want to split the file, I want to go to the data menu. I want to go to the data menu. One option is available, split file. One option is available, split file. If you want to split file, you can go to data, split file. If you want to merge file, go to the data, select the merge file, right? Split file, merge file. So write down the step, otherwise everything go to manage. Okay, so select the split file. Which option we want to split the file, machine number wise or disc brake diameter wise? Which is our option? How we can split the file, machine number or diameter? What is the purpose? We want to split the file using the machine number. First machine, this is the disc brake. Second machine, the product of second machine is this. So I want to split the file machine wise, right? I want to split the file machine wise, right? So I want to split the file machine wise. So I can choose so compare group, right? Compare group. right? Compare group, select the machine number and move it, right? Compare group. We want to split compare group, right? And then click OK. And then click OK. So one message, split file layer by machine, right? Short case by machine, split file layer by machine. One message should come like that. So no problem. Now we can go to select this one. Now the file is available. So go to the analysis, then compare means one sample t-test. So test variable, what is the test variable? Machine number or disk break. So disk break is the test variable. The disk break size is equal to 322. 322, right? So select this one and click OK. Then you can get the results like this. Could you see the results? The share is okay? Okay.
Okay.
Right? Here, the machine number, the first machine number, second machine number, and so on up to, there are 8 machines. So there are 8 machines number. Each and every machine produce 16 number of item. The first machine number mean value is equal to 321.99. Second one 322 point odd, 321.321.99, 322. So every machine mean diameter is given, right? So the standard deviation and standard error mean is given. And then next table. So first machine, this is the significant value. First machine produce disk break. So the significant value is 0.602. The value is higher. What is the symptom? The quality control definitely reject the machine one produced sample. The quality control definitely reject the machine one produced sample. Why? The significant value is greater than 0.05. What about the machine number 2? Machine number 2, the significant value is equal to 0. This one less than 0.05. So the quality control accept the machine number 2. So the third one, disk break 0.522. So this one is greater than 0.05. Machine 3 is also rejected. Machine 4, 0.02, less than 0.05, we can accept. Machine 5, reject. Machine 6, reject. Machine 7, accept. Machine 8, reject. Is it okay? So what are the machine accepted? Machine 2, machine 4, machine 7 only we can accept. Is it okay? Clear? Or otherwise I want to repeat it again. Hello. If you have a problem, just no need. Please chat. No one can't see. No, I can see only.
For
If
me,
I
okay,
want to
sir.
repeat, it's okay. Up to now, it's okay. No?
For me, okay, sir.
Okay. So then we can move. Okay. Okay. Right? So one sample t-test. The sample is given. You can directly compare the sample. Total sample mean is equal to this. Then you can check whether nothing only you can check the sample size equal or not. So many different sample is given. We want to check whether that sample follow the rule, second sample follow the rule, then you can split the file and do the rest, right? These are the two methods or two different type of question. Not two method, two different type of question is available in one sample t-test. That's all, right? One sample t-test is over. Right? In this example, teachers, how to perform a t-test in Excel. The t-test is used to test the null hypothesis that the mean of two population are equal or not equal, right? Say here, we want to check whether the mean value of these two population are equal or not equal, right? That's all. Say here, female, male, below you can find the study hours of 6 females and 5 females, 5 male students. Here, study hours is given, right? Study hours is given. We want to check whether male and female both are equal study hours or not equal study hours, right? Male and female, they are studying equally or not equally. So you can choose the data to sample assuming unequal variance, right? So this one contains 6 values, this one contains 5 values, is not a problem. Whether we want to check whether the mean value is equal or not equal, right? Mean value is equal or not equal. That is the only one case we want to check, right? So due to that, what shall we do? In Excel, we can enter the data and check whether both these groups mean value is equal or not equal. If any problem to enter this data in Excel, I want to enter this data in Excel, I can, no problem. Shall I enter? Oh, shall we work? Why we want to skip? Right? Say in Excel, could you see side by side two screen?
No, sir.
Right. Say now the value is 26, 25, 43, 34, 18, 52. Right? Male value 23, 30, 18, 25, and 28. Right? These are the data given to us. So in this example, go to the data menu, click the data analysis. So choose the t-test assuming unequal variance.
Sir, excuse me, sir. I can't see the screen, sir. Excel screen.
That's why I am asking side by side. There are two screens I am sharing. Could you see? Okay, now it's okay, no? Now can you see, no?
Sir. Okay, sir. Now okay.
Right? So data, go to the data analysis and select the t-test to sample assuming unequal variance. Click OK. Select the first range. So the label is also selected. Second, the second range, right? What is the hypothesized mean difference? Hypothesized mean difference is equal to mu1 minus mu2 is equal to 0, right? Mu1 minus mu2 is equal to 0. Aha. Mean difference is equal to 0. Select this one, choose this, put it here, click OK.
Sir, can we put the mean difference in the mean value, sir?
Mu1 minus mu2, mu1 minus mu2. We want
That's
to,
the mean difference, no, sir?
yeah, actually that is the mean difference. I think mu1 minus mu2. Yeah, we want to put mu1 minus mu2. Then we want to calculate average. Average for this value and average for this value. Yes, actually that mu1 minus mu2, right? That is the mean value, mean difference. So we can deduct 33 minus this. Right here, this one is available. Data analysis. Okay, then we can put 33 minus 24.8. Right? Click OK. It couldn't accept. So we can deduct, can put the values like this. .2, but I think the purpose of this test, we want to check whether there is no more difference between the group 1 and group 2. Mu1 is equal to mu2, right? Mu1 is equal to mu2. Mu1 is equal to mu2. Okay, no need to put this. Why? Here, sorry, suddenly I confuse. Here, in this case, right, we can choose the female data, we can choose the male data, right? So what is the assumption? The first assumption is mean value of the first group and mean value of the second group is equal. That is the null hypothesis, right? The mean value of the first group and mean value of the second group is equal. What's the mean difference? What's the mean?
No, okay, sir. 0, sir.
0.
Okay, sir. Okay, sir.
Right? So if you are asking the question, suddenly I collapsed. Right. Okay. So then click this one. Click OK. So here, this one two-tailed test, the value is equal to 0.1843. This value is less than 0.05, not less than. So we can reject. We can't reject the null hypothesis. Why? The value of t greater than 0.05. Is it okay? Wait. Is it okay? Shall I go to the SPSS? Shall we go?
Okay, sir.
Shall we move?
Okay, sir.
Okay. So, okay, I will repeat the thing. In this case, female and male, there are two groups. Female and males, there are two groups, right? Here, we want to check whether the mean value of the male and mean value of the female is equal or not equal. The concept is mean value of the male and mean value of the female is equal or not, right? So due to that, we can enter the data and check these two groups. We have no problem how many numbers is available inside the column. Why? We want to check whether the mean value. We are not worried about how many numbers is available for each and every column, right? Only we can check whether the mean value of the first column is equal to mean value of the second column. So go to the data and data analysis. Go to the data menu and data analysis. Select the two sample assuming unequal variance. Click here. So select the first group. Click here, select the second group, select this and label. Here, the hypothesis mean different. Our assumption is, our null hypothesis is, the female mean value is equal to male mean value. Female mean value equal to male mean value. Both these mean value are equal. Both these mean value are equal. That is our null hypothesis. When we are deducting mu1 minus mu2 or mu female minus mu male, that is equal to 0. That is our null hypothesis. So due to that, we can check whether the value is equal to 0, right? So the label is already inserted in this line. Due to that, I can tick the label. And where do you want to display the output? So choose the output area and click OK. The output value is display, right? So here the value, the test value is equal to two-tailed test, equal or not equal, right? Mu1 minus mu2 is equal to 0. Mu1 minus mu2 not equal to 0. So the test is two-tailed test, right? I will close this window, Excel. Go to the file menu, choose a new file, enter the data, right? So normally, this is very important thing, right? Could you see the SPSS screen?
Yes, sir.
Yes.
Okay. Say it has some problem. So when you are see this menu, right? When you have see this menu, when you can see the menu is look like this, right? In our data, where is the file? I made my file. Right? The data is like this. When you are see this data, can you see side by side the question and SPSS menu?
Yes, sir.
Okay. The question is display female, male, right? Now our SPSS is display look like this. Then what shall we do? Don't type. Then you can type female. Female, the type is numeric. You can set the width is equal to 3, no more decimal, and male, right? Male numeric. Don't type, right? Like this. Go to the data view, female value, male value. Normally you can enter the female value 26, 25, 43, 34, 18, 52. Male value 23, 30, 18, 25, 28, right? If you are entering the data like this, right, and go to the analysis, compare means, independent sample t-test, right? Independent sample t-test. If you enter the data like this and go to this stage, now you have a problem. Here, where is the test variable? Where is the grouping variable? In SPSS is asked, what is the test variable? What is the grouping variable? So in this case only we know our data entering method has some problem. Why? We can't enter the data like this. In SPSS, we can't enter the data like this, right? I cancel this one. Why I did this? Because if I am not say this one like this method, you have a problem. Go to knock this stage, then only you can realize what's happened. How can we enter the data and all? So normally in the variable view, first one grouping variable, right? First one is grouping variable. Grouping variable is numeric, right? Second one, gender, right? Now I turn it. Here, first one, gender, not gender, is marks, no? Marks, this one is gender. Gender and marks. So here, marks is given 26, 25, 43, 34, 18, 52, right? All these marks are come from 0. 0 means female, right? Rest of them male 23, 30, 18, 25, 28. Rest of the groups are come from male, right? So in your exam paper or question paper display some other format, we want to convert the data in SPSS format. This is the difficult task. This is the main, not difficult task. This is the main task, how we can organize the data. If you are entering the data in two sample t-test, so equal or unequal data, you have to enter the data, look like two group, but not like the paper model. You have to change the group. What is the grouping variable? What is the test variable, right? So if you have to enter the data in SPSS, then analyze, compare means, go to the independent sample t-test.
Excuse me, sir. Before that, we want to split the data, no, sir.
This one,
Two types, 0, 1, like that.
yes, because female you can put 0, 1 or 1, 2, whatever value you can put it. When you are entering the data, you have to group, which is 0, which is 1, which is 1, which is 2. Could you understand?
Then we want to check the mean value of female and male, both.
Yes, yes.
Okay, sir.
Test value is what about the marks? What about the marks? So actually, there are two different female and male students. Marks is given. So marks are equal or not? No. So we want to check whether the marks is equal or not. Okay, I will repeat it. First, I will go to complete this one and come back, right? So gender. Gender is our test variable, right? Gender is our grouping variable. We can group, right? We can group, right? We can group. How we can group? Female is equal to 0, male is equal to 1, right? And test variable, I want to check the marks. Check the marks, right? Define the group. Group 1 is equal to 0. Group 2 is equal to 1. Group 1 is equal to 0. 0 means group 1. 1 means group 2, right? Continue. If it is okay, then you can click OK. Here, in this stage, here the t-test value is given 0.187, right? The equal variance not assumed. Variance are not equal. So variance are equal case is given. Variance are not equal case. In the Excel case, I select variance are not equal. So I got the value, significant value is 0.187 something, right? So the value is coming here, right? So this is the grouping, this is the significant value. This value is greater than 0.05, then we can reject, right? I will repeat. I will repeat. Here, why we want to enter the data like this? Yeah, there are two variables, male and female. Two variables, male and female, right? Say, if you want to check t-test in SPSS, t-test in SPSS, you can put the value like this. One is the grouping variable, then the test variable. What is the grouping variable? What is the test variable? So don't enter the data like female, male. You can put female 0, male 1. You can group that data into 2 separate groups. So this is the data comes under female. So gender 0 means female student. Gender 1 means male student. So the data can be remaining same concept, same thing, no more changes, but we can enter the data in some other different format, right? Why we want to enter look like this? Because in our test statistics, we want to give one grouping variable, one test variable, one grouping variable, test variable. The grouping variable can be group. Who is the person come from 0? It can measure these. Those are group 1. Who are the person come from 1? They will assume the group 2. So they can divide 2 groups, 0 or 1 or 1 or 2. So due to that, we can enter the data like this format. So whatever format the data is given, we want to enter the data in t-test. One is the grouping variable, another one is the test variable. If the grouping variable contain only 2 groups, 0 and 1, and test variable contain marks of the test variable contain what is the thing we want to check, right? So in this format, we can arrange the data, right? In this format, we can arrange the data. When we can arrange the data in this format, then only that possible to test t-test, right? Then only it should be possible to test. Is it okay? Hello? Hello?
Okay,
Up to
sir.
this, okay? Up to this?
Okay.
So I try to stop up to this end. So only one sample t-test, Excel in SPSS. T-test unequal variance, t-test unequal variance, right? T-test unequal variance. How we can implement this one in Excel as well as in SPSS, right? If you have time, you can practice this. If you don't have practical possibilities, no worries, no worries. Keep in your mind. Or when we are go through this one, you can, if you want, I can give a time. You can take short notes. Which format you can write down, you can understand, you can take notes, right? That's all. So very few tests is available. So no need, we have enough time. So we can see in the next class. Are you okay? Or I want to repeat it again. Let me know. I have no issue. I can repeat it again. If you want, I can repeat it. Anyone? So if you have a fear to, or if you have a shy to say, send one SMS, I can repeat. Everyone is okay, clear. So shall we assume everyone is okay, clear? Okay, right? Okay, right? We can see in the next time. Thank you. Okay, so in SPSS, in SPSS, here name, what is the variable name, or what in the data view, what is the name if you want to display in the top, right? In the top, what is the variable name should be displayed. You can enter that one in the name row, right? You can enter that name in the name row. So if you are enter this one, if you write down this one in this cell and enter the key, then automatically the numeric is the default option will come, right? Default option will come. So scientific notation, date, time, dollar, custom currency, string. If you want to enter string letters, then you can choose string. If you want to enter number, you can choose number, right? If you enter currency format, dollar, rupees, whatever, you can enter custom currency format. If you want to enter any other notation, you can use notation, right? Okay, I try to share the videos. So I think next week we will return back to normal. So then I can send the file, right? So then you can select the numeric and then select the width and decimal. If you want decimal, then you can put 1, 2, 3, 4, whatever decimal do you want. So no need the decimal, you can put 0. In this way, you can arrange this one. So with decimal label, label means label. So in front of the liquor bottle, they mention don't drink this. So that is the label. What you want to display, that is the label. If you want to elaborate anything about gender, you can use to enter that one label. Values, you can enter some default value is available. If you want to enter that value, then you can select the values. If the value is 1, means this. If the value is 2, means this. If the value is 3, means this. If you want to enter this type, say the height of the person, he is short, he is tall, he is mid. So if you want to categorize like that, you can enter the values and labels, right? Missing value. So if any value is missing, if you don't enter, you can skip the values. In that time, if you wish to display some messages, you can use the missing values column, right? And then column alignment, right or left. Here there are 3 different type of scaling mechanism. One is scale. Scale means whatever you want to measure. Yeah, you can measure whatever thing. You can say scale. Ordinal and nominal. Ordinal arrangement, it's an ordered arrangement. It's an ordered arrangement. Then you can say that type of data is ordinal data. Grading, right? Grading. So say grade A, distinction, credit, pass. So grade, you can arrange, that is the ordinal arrangement. Otherwise, ordinal data, nominal data is available. You can see what do you mean by the term ordinal and nominal. So if it is ordinal, then you can choose ordinal. If it is no more group, if it is no more ordered arrangement, no more scale, then that thing come to nominal. That's all. You can enter the data, name, time, width, or whatever you want to set it. That's all. I heard about Mr. Werner Koban also take 201 class, very fundamental stuff, very fundamental thing about the SPSS. Is it correct? So I thought he explained this stuff.
Yes,
If you
sir.
want, I can repeat it again. So no problem. We can go slowly, but clean. Today, if you have a problem to complete these 2, completed. That's all, right? So check whether if you have any problem, we will repeat it again, right? Thank you. I will send the files and video clip as well. So if it is possible, in my mobile number, normally you are entering my mobile number. Now, if you have any email address, WhatsApp or whatever, whoever, please send one email address. I can attach the file. Right? Thank you.